already like covered almost all the basic essential things that you actually need to know when you are like deploying your own application. And I almost talked about most certain application types that they might be connecting with SSH or FTP or using cPanel or things like that. And now with today's session and tomorrow's session, we'll learn about the most popular cloud and web service providers, which includes AWS, stands for Amazon Web Services, DigitalOcean, Google Cloud Services, Google Cloud Platform actually, and then Azure, Microsoft Azure. So we'll go into each of one of these services and we'll look closely that what are these services, what kind of services they provide. Or like I'm too certain that I cannot cover all these application services because it's a vast pool of certain like of applications that they provide. But guys, you have to be totally certain and clear about this thing that this differentiation between the names of different services is just for marketing and packaging purposes for this cloud providers, right? They have to compete with each other, they have to stay ahead of each other. That's why they want to replicate each applications that they are providing. AWS right now is the biggest cloud provider in the world. Almost 37% of internet goes through AWS right now. So 15% of which is just Netflix. So Netflix is the biggest after Google search. Netflix is the biggest consumer of internet bandwidth, and Netflix is fully hosted on AWS. Even though AWS has its own Amazon Prime services, which is competitor of Netflix, but still their business line doesn't interfere on the cloud side. And you will be surprised to know that AWS makes up to 70% of the total profit share of the total Amazon business. So AWS is a very profitable service for Amazon. So whatever they learned from developing their website, Amazon.com, they learned and created an infrastructure so that everybody can use, and that is how AWS was born. Then recently, DigitalOcean is also a very good platform solution. Like if I have to define DigitalOcean in one word, I would say that it's very simple, the simplicity it provides. So we'll cover both of these applications today. We'll see what are the most important services that you should know as an application developer and how you can deploy your own application on these services. So we'll cover the name of these services, how you can deploy, what is the architecture that you should consider in order to have the maximum redundancy and good speed and scalability. So we'll cover all of these things in today's session. Thank you for joining. So let's begin. And not to mention, I am Aman Sharma. And so agenda will be AWS hosting and DigitalOcean. DigitalOcean hosting, I have just like defined it like this because we are going to go not much in detail, but in a close overview of what are these things. So let's start with Amazon Web Services, as I already gave you a little bit of introduction of what Amazon Web Services is. It's a cloud provider, cloud VPS, managed hosting, all these services. Like they cover everything almost. They cover almost every aspect of what a today's next generation web application can do. So if you ever imagine like a web application is able to do IoT, so AWS has a solution for that. Can you host a database? AWS has a solution for that. Can you host big files? AWS has a solution for that. Can you do ML and AI? AWS has a solution for that. Can you do auto ML of Google Cloud? AWS has a solution for that. So AWS has almost everything that a web application can do today. So not almost, I think everything. So they just try to, every day, every year they have AWS conference, and then I don't know what's the name of that conference they call it. Amazon AWS something. So there is a keynote thing that goes on, and then they are trying to add all services as possible. Recently they added a new service which was very weird to me. So now you can connect your satellites uplink directly using Amazon Web Server. So the application can directly use a satellite uplink. So they are providing the services to Pentagon, and that was very surprising for me. They also have a service called as Amazon Snowball, and that is a little bit weird for me. What Snowball does is it provides CIA or FBI field agents a remote compute that they can copy the spy information as soon as possible. So these kind of applications AWS is providing. So these are very kind of weird for us. But today we will concentrate ourselves into the most application important ones. So here is a small diagram that tells about how AWS differentiates its different level and different tiers of application. So basically AWS has its own global infrastructure which is spread over different countries, continents, and they have their own availability zones. And I think there are 17 availability zones, and within availability zones they have different kind of redundancy locations again, but you don't need to worry. You just need to choose the location and it would do the job yours itself. So this part is actually covered totally by AWS. Then you have your own foundation services. So foundation services are those services that are very, very important to run your application. Without these, you cannot do. So the first one that comes in mind is compute. Then you have storage. There are different forms of storage that it provides. Then it's networking. How does it communicate? And then databases. So this is the easiest differentiation that you can do. You have compute that computes, storage that stores, networking that network your application, and database that stores the database data. Then you have application services. These are application services are those things that are managed by AWS to perform a simple task like content delivery network. So you have CloudFront, which is a direct competitor of Cloudflare. And then you have networking in terms of sending notifications and things like this. So you have SES, NSS, and SQS. We'll learn about SNS also. Then you have a search service that is called Cloud Search. You have distributed computing, which is nothing but kind of fancy word of saying that you can create your own mainframe supercomputer on AWS Cloud. Then you have your own libraries and SDKs, different applications that you can install over foundation services. And then finally, you have your deployment management services, with which you can monitor and control, give the access to someone, these things like that. So these are the three main services. This is the easiest that I can explain how AWS actually works. So to quickly recap, you have your own AWS global infrastructure, which you don't need to do anything. You just choose a region. Then you choose a foundation services according to your needs. Example, if it's a computational thing, then you choose a compute and things like that. Then you have application services on top of it. Then you deploy your application and you write your code on top of everything that you have just configured. So let's go ahead and see each of these services one at a time. And I will also try to show you a live demo. I have an AWS account. Twimbit uses some of the AWS services for running its day-to-day jobs. I won't reveal actually what are these due to security reasons, but I can show you the overall console. So first one that comes along is Amazon CloudFront. It's a content delivery network. What it does is that whichever application you configure with CloudFront, it will create the copies of that application and store it in multiple regions. And it provides an easy API level interaction point that you can communicate with the application with very ease. So that is what it is providing with Amazon CloudFront. It's very easy to configure. So let me see if my browser is open. Yeah, and to go to AWS, you just need to go to aws.amazon.com, sign into your console. By the way, like other services, AWS doesn't require any credit card beforehand, which is very good thing. So everything that runs on AWS runs on postpaid. So it means that you firstly consume the services and then you have to pay later. And they have, I think, how much free credit? AWS free credit. Okay, so this 2000 is for, I think, startups. Yeah, free tier. Some of these applications will always be free, like EC2 and all these things. So this is a good thing if you want to get started. And if you exceed this, then only you have to pay, and that is also postpaid charge. So even if you don't pay for 2 months, they will be giving you notice, and then after they will be shutting down the service. And still they won't be deleting anything. They will just be giving a warning, and your application will be suspended for some meanwhile. So this is how it looks like when you log into AWS. Some important things to look here is your company information, where you can configure your company details and everything. And this is the region part that we are talking about. Some of the applications are central. That means they don't need any region specifications. But most of these applications like EC2, S3 are very, very location dependent. And that's why you have to consider whenever you are launching an application or whenever you are inside it, you have to take care about the location. So if you are inside one location, you go to EC2, you won't see anything. But if you are in another location, you go to EC2, you will see something else. So we were talking about CloudFront. So let's go into CloudFront. And in order to access all these applications as once, you can go to the let it load. Yeah, you go to services on top and you will be able to see all the applications that we talked about, all the compute. These are different marketable products that they have created for compute. Then for storage, they have created this. Then you have database, migration. So the one that we were interested in was CloudFront. So you go to networking and content delivery. You have your CloudFront service over here. So let's see what access is over here. Yep, so I have set up already a simple CloudFront service for Twimbit, and this is used for our media assets. And CloudFront is right now, copying all these kind of content from our storage, and it is storing it on different parts of the world. Let me see if I can show you. Yeah, cache statistics can be an important thing if you want to see. So this totally shows how much hits and misses we are going, and our hits are more than misses sometimes. So that means more often that CloudFront is providing service rather than our own actual hosting service. So this is a good part that why you should use CDN, and that's how we have configured the CDN. I won't go too much detail because it's a little bit slow process how you actually release the CloudFront distribution, and also it's a lengthy one. So I would definitely recommend that there are very good uh, tutorials out there that you should definitely go and check out to see how CloudFront actually works. But to quickly summarize, CloudFront works on top of any application that you have created and creates a redundancy, different copies of these applications in different regions. You can choose which regions that you want to deploy it in, and at what configurations you want to do. So those things are, you should definitely check them out and go in detail. So next one on the list is Route 53. So I don't know why they have named it Route 53. It's a little bit complicated on how to learn the name of these services at first from AWS. But if you just get a grasp of it, then it's pretty easy. So Route 53 is the place where you manage your name server and domains. That's it. So the place where we call the DNS manager or DNS zone editor is actually Route 53 in AWS. So if I go inside my AWS and let's kick into Route 53, which should be inside networking. So you go inside Route 53 and you can configure all the details, schema and everything about your domain over here. So there are different hosted zones, and I'll go to one of the hosted zones for twimbit.com. And here you can see I have different name records as we learned in the last class about name servers, about A records. So all these records are saved over here. So what you used to do with your other services in terms of record saving, so you do everything inside Route 53. Not much any complicated thing about here. They don't provide anything extra. It's just like how you can configure different name servers. You can directly point a certain domain name. For example, this in my case, I have pointed this directly to the CloudFront service, so that cdn.twimbit.com is actually canonically representing this service that AWS is providing. So this is how simple it is. It automatically, configures internal routing of these applications. So whenever someone comes to your website or application, he actually enters to Route 53 first. Without Route 53, you cannot configure any application. And then Route 53 decides that which server it has to call and which application it has to go on. And this is a very important part of understanding how you can direct different applications on different settings. That's pretty easy. Just go and add the record that you want to add, and it will start working. Then AWS EC2 is the most popular and most used service on Amazon. What Amazon EC2 stands for is Amazon Elastic Compute Cloud. So as the name suggests, it's a cloud service. It's not a VPS. So what it does is Amazon has a large pool of servers, okay? A large pool of server farm located in different data centers. And with EC2, what you do actually is you can get a small share of that large compute. This is generally done by doing virtualization on these servers. So they create small virtual spaces, as I discussed when I was discussing in cloud hosting. So you can easily create and resize your compute service according to your demand. So whenever you have high demand, you can increase the space that you were taking over this server farm to X number of servers, and when it reduces, it will bring back to normal. So a common example for this is IRCTC used to use self-dependent self-dependent data centers. So that was provided from Satyam computers at that time, and you might be familiar if you have used the IRCTC before. So they had name of server like Yuvraj, Bhima, Bhishma, I don't remember the name of the data centers actually, but they were saying something like this. So what they actually used to do, they were distributing the person who is coming to the application to different domain names and different servers, which was pretty stupid, because they have to pay for the server anyways when the peak demand is not there, which is during the Tatkal time. But then recently they had some new application developer, they remodified the UI and everything. But one more thing they did, they migrated all their services to Amazon EC2, specifically EC2. And there is a reason, like I did a small digging and I found that the reverse track of this actually goes to Amazon EC2. So Amazon has its some of its server in Mumbai. So IRCTC took some of these applications and launched it on EC2. So now whenever there is high demand, they have auto configuring code that actually automatically scales when the call demand is high. So they don't need to pay anything extra. Same is the case with Netflix. So whenever they have a peak season, whenever a new movie is released, they increase the compute, and when they don't need it, they can just bring it back to normal. And it's really easy to actually deploy an application with EC2. So let me go ahead and show you how does EC2 deployment looks like. We haven't deployed anything on EC2. We use a separate cloud provider for our compute resources. But this is how it looks like, that when you go inside EC2, you have this dashboard kind of zone. And now the interesting part is, if you go and change your availability zone, everything that is listed over here will also change. Why? Because everything is distributed according to the availability zone that you are checking that service in. So availability zones are different geographical location, and inside those geographical location, you have your own compute, storage, whatever you have created. Yeah, so you can see there are different key pairs and security groups. To just kick in and launch a new instance, you just go and launch instance. So instance is the name that they have given for the VPS, virtual system machine, that they will give you, and that is actually a shared machine out of the global farm of servers that they have. So some important things to consider before when you are launching EC2. So you need to configure the hardware first. What kind of, how much RAM you need, how much computation you need in terms of processor, how much storage you need. All these things you can configure with EC2. So to attach a small disk drive, that is SSD, you use EBS, elastic block storage, and that can be handy inside there. So you are able to see this option over here that is called EBS, and you can attach a volume of EBS directly to this thing. So this is like a processor and RAM, and then you attach a small storage so that things can start working. And then for big storage, you use something else, that is S3, and to store you use databases, that is RDS. So this is how a sample scenario looks like. It takes a little bit of time. I don't know, it's ease of use, but the way that Amazon launches everything is a little bit slow. So first of all, you choose a AMI, that is Amazon Machine Image, the same as choosing if you want to install Windows or Ubuntu on your machine. So you can choose different applications to install with. So after you choose applications, then you, for example, let's go ahead and choose this Ubuntu service. Then you choose how much system application you need. This one is free, totally free, and free for always. But the problem is, as soon as you can obviously switch back these applications whenever you want. So for example, if you go with this application right now and your demand increases, you can change the configuration from T2 micro to something like T3A large, which has more CPU and more memory. So according to your CPU and memory consumption, you can choose any of these applications that you want. Then you can just go ahead and review and launch, which I won't do because it will start charging me, and I actually don't want to use. And the next thing is that you configure the instance according to different networking zones. More often that you won't be actually needing it, and you can actually create a new networking system, that what are the domains that you should point to this VPS. Then you have storage that I was talking about. So you can add elastic block storage over here. Just choose how much storage you need and which type of storage you need. You need magnetic, that is normal hard disk, or you want SSD. You can choose it from here. Then you can add tags, which is nothing but a way to identify your service. Then you choose a security group. Security group are important to assign which code can be utilized by which service, and which one of them are open and which one of them are closed. And then at last you review everything and launch. So it will create a VPS, give you a notification, and then you can start coding your things on top of this thing. So that was about EC2. Then you have AWS Identity and Access Management, which is just a fancy word to say this is just an admin dashboard to control who can access your AWS account or not. So AWS provide different ways by which you can actually interact with the service. You can have your own SSH console, for which you will need IAM key, identity management key, and then you can have your own root access, by which you can just log in and then you can do that. And then you can also store this log information on a pen drive, so that someone, if they plug the pen drive, then only this application will be launched. You can do biometric setup. There's much more complicated things that you can get in if you want to go that far. But to simply to address, if you have 2 people in your company, one is the main admin who knows everything, and then you have a developer who just needs to access only certain aspects of your application. So you can create a IAM user, that is the developer, and then you can provide only certain permissions to this person, so that he doesn't manages your billing, increase your billing and things like that. But at the same time, he has the flexibility to easily log in and manage the application as he wants. So a pretty good feature over there also. Then you have Amazon Relational Database Service. This is a simple simply understand, this is a fancy way of saying that you can host database over here. So usually when you have a managed hosting, the database service is built in with PHP MyAdmin. But in case of distributed cloud service provider, you have to create a separate instance to launch your own databases. So Amazon RDS is a SQL based database system, as the name suggests, relational database service. So relational is structured query language, so SQL database schema. You can choose among MySQL, Postgres, MariaDB, not MongoDB, because MongoDB is not a relational database service. For that, you can choose DynamoDB. DynamoDB is another fancy cool NoSQL that works exactly like MongoDB. No difference. So again, let's go inside RDS. So for databases, you just go to RDS, and then you will be able to see all the RDS configuration, relational database system. And you can configure and launch any kind of database that you want for your service. So and there is another service that they have just come up with. The name is Amazon Aurora. So this is a cluster kind of database service. So when you go deeper into databases, you will get to know about a term called as node and cluster. So what this means, that usually databases are hosted in a single table, in a single cluster, like one at one place. But if you want more redundancy and more scalability of that application, what you will actually do, you will create cluster and nodes of these databases and distribute it on different geographical location. So they just created this Amazon Aurora, a fancy way of saying that it's a clustered RDS system. And see, this is actually advertisement over here on top, which is just a notification. Just cross it. This is generally expensive than RDS, so I don't care. If you have a big application, then you need to care about all those things, right? So if you have a small application, then you can just go with this simple, create a database, choose which database you want, Aurora, whatever Aurora, and then MySQL, MariaDB, Postgres, Oracle, whatever you want to choose according to your application. MySQL is just fine, and then just kick in. You can choose which template you want to use. If you are not sure, just go with production, and then choose the how much size, how much storage memory you want to give. The bigger the better, but it's expensive too, so choose wisely. And then when you are sure with it, just kick in and then connect. It will see how expensive it is, $611. So I told you just need to configure all these things and consider only when you are sure that okay, I'm going to launch this application. So right now they were launching in Ohio. So again, a piece of advice: whenever you're launching a new service, always consider like launching the service where you are closest to the customer. So if you are an Indian based company, you should obviously choose Asia Pacific Mumbai. They have only one server in India. I think Google has 2. I'm not sure. So you can choose among this Mumbai or Singapore, wherever you want to launch. So that's about database and relational database service. Then you have Amazon S3. Amazon S3 is stands for Amazon Simple Storage Service. So it's a object storage service, blob storage or object storage or static storage, whatever you want to call it. So that means nothing executes when you store something over here. It just stores all these assets as it is on a very high efficiently manner on Amazon S3. So they have named this buckets. Imagine this as different Google Drives or OneDrive. You can store everything that your application needs inside S3 bucket. So just a fancy word for drive. And then whenever you want it, you can get these assets anywhere from in the world from your EC2 instance. So the way you store big media files, MP3, photos or videos, you store it on S3. Netflix also uses S3 to store everything, which are their movies in different encoded formats. So let's go ahead and see how does this S3 looks like. In storage, the first thing that comes up is S3. So let's go ahead and see that. Yeah, so there are certain buckets, they call it, and I have created a bucket that is launched in Singapore right now. So let's go ahead and see what is inside it. Yeah, so you can see that inside my bucket I have certain files and folders that are utilized by our applications. So these are totally encrypted format, so you won't be able to see the name either. So this is how it works. But after you configure everything, you get a high availability application. So as you can see, if you visit mobile-web.com, you will be able to see our application. Something going on with my internet. I don't know, I just need to check. Yeah. So for example, if I go and open this one and I click on this image, now notice that the domain right now is twimber.com, but when I open this image, it opens on our CDN, and that stands for cdn.twimber.com. Let's see if I can track the technologies. No, we can't. So this application is running on a different cloud, and then our media is hosted on different cloud. So just it's a matter of different configurations that you can set up a complex architecture like this. And what it gives, it's a high performance. So this is so fast that even if I load, you won't even notice that it's getting refreshed. And this is, trust me, it's a very high kind of resolution image for this kind of thing. If I host it normally anywhere else, it would take a time to load, but over here, no chance. It would just open instantly. So that's about S3, how you can store different media assets, blob storage, and object storage over there. Next, you have Amazon CLI, AWS CLI, which is a fancy way of typing command line on your VPS or any other tool. It just gives you a command line interface. That's it. Nothing complex about this thing. Then you have Amazon Lambda. So AWS Lambda. AWS Lambda is a serverless way of executing your code. So there is a common term called as serverless, and I would explain you what serverless is. Serverless means that you do something irrespective of the storage compute it needs. And this serverless computation actually determines how much application storage it needs. So a fancy way of saying that there is a person, assistant, that you are saying, okay, you do this job for me. I don't care how much money it takes, just do it, and do it like very efficiently. So that's a Lambda service worker. So a common scenario that if your application is something like a photo recognizer application like Google Photos, so you upload a photo in bucket. We just learned about bucket. So if you want to store anything, you store in buckets. Then you have something called as this is not an application. Basically, this is just a fancy way of categorizing this thing. Then you have a Lambda function. A Lambda function reads these files and then decides which application they want to choose. So this is a serverless application. It can help you scale the service up and down and do the job, and then just store the results, executes the code and only when the user needs, and scales automatically. So this is an important fact about it. So it doesn't cost you anything. If your service is not being used for a whole month, it won't charge you anything, but if it executes, then only it will charge. So in AWS Lambda is a serverless function provider. So what serverless means is that you tell the server to do a job without considering how much RAM or computational it needs. And you don't want the service to actually cost you when it's not running anything. So it's pay as you go model. So a common application over here is when someone takes a photo. So this is a photo recognition application which has distributed functions to do the job. So when a photo is taken, it triggers a function which invokes a Lambda function. Lambda function, it's a different set of codes. So it extracts the data from the image and everything, sends back it to another service, that is Amazon Recognition, again a managed AWS service for object recognition, and then store the result in Amazon DynamoDB. So in whole architecture that we saw here, we didn't configure any EC2 or wrote a single line of code in terms of mainframe code. We just wrote a AWS Lambda code, and this AWS Lambda service automatically invokes whatever it needs to do in order to perform that job. Yep. So then this brings us to the last service today, and that is called AWS SNS. And AWS SNS is a simple way of like knowing it's same like how does different applications give notifications on your phone. There are different ways to receive notifications like email, push in-app notifications, or SMS. So what SNS does is, if your application needs to send out some kind of notification to the person, you can configure SNS to do this job. So what are the things that you can do? You can send SMS from your application, you can send an email, you can send a HTTP notification, that is a browser notification. SQS is another form of sequencing all these things, the notifications in a buffer. You can also trigger a Lambda. So basically, it's a subscriber service which says that whenever something happens on your application code, do this, which can include all the subscribers that we have talked about. So nothing to worry about if you are that person who loves Amazon a lot. So, and you want to do everything with the AWS. So anything that you imagine to create your web application, AWS already has a solution for that. Sometimes simple, sometimes difficult, sometimes costly, sometimes cheap. It's up to you how you want to configure it. So now I will, these were all the main applications that we need to know. Now I will show you some, kind of practical real life scenarios of how people configure AWS. So here is a serverless block. What we mean by serverless, that you don't need to care about how much storage it consumes. It should just work fine and efficiently. So let's see how architecture for a serverless web application looks like. So a person enters to your website using his computer. Route 53 is the place where it directs that which domain needs to go to which application. So in this case, we are going to API mywebsite.com goes to the API gateway, and your my website goes to CloudFront, which is the CDN. So the CDN is on top of a S3 storage. So all your static code for the web application blog is stored in S3. So you are triggering it over there. Then API gateway is providing the backend access to your front-end application, and then there are these Lambda functions, which are the serverless way of communicating with data. And then you have set up a NoSQL database from DynamoDB. So a proper full stack application where your front-end code is on CloudFront as a static website. Then your API is on the API gateway with backend code on Lambda functions, and then your database here is DynamoDB. And then you have Amazon Cognito and AWS STS to monitor and see how your application is working along. So very simple way to understand that how you can set up your own application. Let's go ahead and see another application architecture for a normal web hosting application. So a person goes to your website, DNS Route 53 resolves that request for you. This request goes to Content Delivery Network, CloudFront, which chooses static content to show to you first of all, and then for the code itself or front end or back end, whatever it is, it's a full stack application. Then we have something called as elastic load balancing. So elastic load balancing decides that from which region this person is coming, how much computation it needs, and then it directs that user to a particular EC2 instance. Meanwhile, the domain name and the website is looking exactly like the same. So something like balancing the load so that one server doesn't execute all the job. So it automatically scales. So here you can see that this auto scaling thing that it has written, it automatically can scale from either of these direction, and load balancer can automatically assign this job to any of these web servers. And so you have zone A and zone B. These zone can be different geographical location. You can increase the location in India or maybe in US depending upon demand of that application. And then you have another, so this may be the front end code. Then you have the back end code, elastic load balance. Again on that, you have again a EC2 running on that. And then you have Amazon RDS as the SQL database that is running on the back end to like fetch the database code. And again, it is also auto scaled, so you have different copies of this server stored, so that if one fails, then other one can provide assistance. So another simple way of understanding how a web application can be configured. So with this, this is all about AWS. So let's go ahead with DigitalOcean. Again, DigitalOcean is another web service provider, which is in direct competition with Google Cloud, AWS and all that. But the one thing that I like about DigitalOcean for small application developer like us, that it's really simple to kick in an application on DigitalOcean, and it doesn't has too many services, so it's very easy to understand. So first thing that we'll know about is DigitalOcean Droplet. This is a fancy word that they have given. So DigitalOcean Droplet are virtual machines that are running on top of virtual private servers. So each droplet creates a new server for you, which is among the shared storage that it already has, and then you can compute whatever you want to do. So it's kind of a fancy transformation of EC2 if you consider, and it's actually a VPS service, but they have named it DigitalOcean Droplet. So let me go inside my again to introduce this DigitalOcean also for some kind of features. Again, I cannot totally tell you what are these things. But you know, when you develop a company and you have to be sure that okay, you don't have a problem like vendor lock-in. So vendor lock-in is the situation when you are stuck with one provider, and that provider can increase the billing whenever they want. So that's why we distribute our application across different cloud providers. DigitalOcean is also one of them. So here is the droplet, and I already has created a droplet that is a test droplet. And a droplet again contains some configuration like how much RAM, how much CPU it has, which location it is running on. Right now it is running in Bangalore. So DigitalOcean has its server in Bangalore. and you can say it by BLR1. And then you have the cost. It's so DigitalOcean is also very cheap. Normal droplet cost you around $5 per month. If you want free credits for droplet, you can go and check out your GitHub student pack. They have a DigitalOcean $50 credit, so that means you can run your application on DigitalOcean for 10 months for free. So go with it, like definitely give it a try. So if you want to just create a new droplet, just go to droplets and click on create, and choose whatever configuration you want. You can even install predefined applications such as WordPress, Ghost, or anything like that. So you have a lot of applications over here. You can install a Docker AMI over here, and you can onboard your own Docker image on top of it, so that it's just a plug and play configuration. Then you can choose a different performance mode like general purpose, CPU optimized, or memory optimized. General purpose should be fine most of the time. And then you can also choose the standard one. Then you choose the location. So Bangalore is one of them if you're launching in Bangalore. So, but if you have another demand in other cities, you can choose that one accordingly. And when you are ready, you just kick in and it creates an instance for you. So when it's the instance is ready, the droplet is ready, it looks something like this, and it gives you all the statistics and everything, that how it is going right now. And to attach a new domain name to this thing, there is a certain place which we will learn in our next slide. So yeah, for database, you can go to DigitalOcean Managed Database Service. Again, it's a replication of Amazon RDS, and you can create your own databases in Amazon Database Services. We don't use this service, but you can use Postgres, MySQL, and Redis. Again, these are just SQL databases. You cannot host NoSQL databases on DigitalOcean. Okay, and just a fancy way of saying yes, you can host databases, manage these host databases, and then you can get your request from these databases. That's it. Then you have DigitalOcean Network. So DigitalOcean Network is responsible for picking up your website, and it is pointing it to different services. So for example, if your website is devrant.io, I don't know what this means, then you can assign a floating IP to this thing, which can go to a droplet, and this droplet can cause like a series of commands that runs in background to fulfill your application. So basically, if I go in the networking portion, I have my one domain that is set up wimbit.co. This domain currently is pointing to a subdomain, and this subdomain is pointing to this IP address, and this IP address is for my droplet that I have already created. If you see, so I have created a domain name inside network. Again, you can add different records like a name, c name, a record, ns name server. Everything you do for records and everything is stored over here. So when you are ready with your application, you just copy your domain name from your domain name provider, add it over here, and then all the website traffic is rerouted and directed accordingly. So, and when you are ready, it's, you just go to your application and everything looks cool like this. Okay, so this is just a simple way to say how you can point your different websites to different places. That's it. So then you have DigitalOcean Space API. This was recently released. I haven't fully checked it out, but I really like the concept. So what they say that you can add your backend code to this application, and it provides you an API level abstraction. You can create your own backend API, and you don't need to worry about how much storage or application that it is using. It's like amazingly well, it just scales automatically. Yeah. Interoperable with Amazon S3 API, following it interacts with services while using tools. So yeah, the basic thing that about Spaces that I liked was you remember that S3 part that I was telling about AWS, where you can host any of the kind of storage and you don't need to worry about how much storage is consuming. So Spaces is the exact same replication, a copy of S3, and then you can migrate your Amazon S3 files over here. So you can also configure CDN on top of it if you want. You can configure which location you want to release in. So that is about Spaces, to have blob storage or static storage. And that's that brings to us to the end of DigitalOcean also. These are the main things about DigitalOcean. Let me go and see if there is anything else that's important. You have clusters for Kubernetes. People who know Kubernetes will obviously understand cluster. Then databases I already told you about. Volumes is again like volume storage to your droplet. This comes built in. So whenever you launch a droplet, you have to choose how much storage you need, and a volume will be assigned to it automatically. So that is why I never created volume myself, but whenever you create a droplet, it comes with a volume storage with itself. How I know about that? If you go inside the droplet and go to volumes, you will be able to see a built-in volume inside it. But if you want a dedicated volume, you can just go inside and have a volume over here. Then these are networks, domain DNS, cloud firewalls, floating IP, load balancer, and then these are alert policy to monitor everything. So this is a simple cloud infrastructure. If you want to start your application, you can start on DigitalOcean. It's pretty easy and smooth, the overall process, and they have very good documentation and support. They also have, I think, chat support. So they help out developers at every step. Not like AWS. AWS support is good. It's amazing. But in terms of developer support, there is some additional cost, which is pretty expensive. It's like 15,000 almost every month. So not a good deal. But DigitalOcean provides, I think, developer supports free of cost to you. So that's about AWS and DigitalOcean.